Serverless computing, an overview. Serverless computing is a cloud computing model where the cloud provider manages the infrastructure, allowing developers to focus solely on writing code. In a traditional cloud computing setup, developers must manage and scale servers to handle their applications. However, with serverless computing, this responsibility is removed, as the cloud provider dynamically allocates resources based on the application's demand. This model enables developers to build and deploy applications without worrying about server management, scaling, or infrastructure maintenance. How serverless works. In serverless computing, applications are broken down into individual functions that run in stateless compute containers. These functions are triggered by events, such as HTTP requests, database changes, or file uploads. When an event occurs, the cloud provider automatically allocates the necessary resources to execute the function. Once the function has been executed, the resources are released. This on-demand resource allocation ensures that applications are only using resources when needed, leading to cost savings and increased efficiency. Key concepts in serverless computing. Function as a service. FAS is the backbone of serverless computing. It allows developers to write individual functions that perform specific tasks, which are then executed in response to events. Each function is independent and can be scaled automatically by the cloud provider. Fast platforms like AWS Lambda, Google Cloud Functions, and Azure Functions allow developers to deploy and run these functions without managing the underlying servers. Event-driven architecture. Serverless computing relies heavily on event-driven architecture. Events trigger the execution of functions, and these events can come from various sources, such as HTTP requests, database updates, or message queues. This architecture allows for highly responsive and scalable applications, as functions are only executed when specific events occur. Statelessness. In serverless computing, functions are stateless, meaning they do not retain any data between executions. Each function execution is isolated, and any required data must be passed into the function during the execution. This stateless nature ensures that functions are lightweight and can be scaled easily across multiple instances. Autoscaling and pay-as-you-go. One of the most significant advantages of serverless computing is its ability to scale automatically based on demand. The cloud provider handles all the scaling, ensuring that the application can handle sudden spikes in traffic without any manual intervention. Additionally, serverless computing follows a pay-as-you-go pricing model, where you only pay for the compute time used during the execution of functions. This model is cost-effective, especially for applications with varying levels of demand. Real-life use cases of serverless computing. Serverless computing is ideal for building web applications that experience variable traffic. For example, an e-commerce website may see a surge in traffic during a sale event. With serverless computing, the website can scale automatically to handle the increased traffic, ensuring a seamless user experience without over-provisioning resources during off-peak times. Microservices architecture. Serverless computing is well suited for microservices architecture, where an application is broken down into small, independent services that communicate with each other. Each microservice can be deployed as a serverless function, allowing for easy scaling, deployment, and maintenance. This approach also enables developers to update individual services without affecting the entire application. Data processing and analytics. Serverless computing is often used for processing large amounts of data in real time. For instance, a company might use serverless functions to process and analyze logs generated by its applications. As new logs are generated, they trigger serverless functions that process the data and store the results in a database. This approach allows for scalable and cost-effective data processing without the need for constant server management. Real-time file processing. Imagine a scenario where a company needs to process large volumes of files uploaded by users. For example, a photo-sharing platform may use serverless functions to automatically resize and optimize images as they're uploaded. Each file upload triggers a serverless function that processes the image and stores the optimized version in a storage bucket. This approach ensures that the platform can handle a high volume of file uploads without manual intervention or server management. Conclusion: serverless computing represents a significant shift in how applications are developed and deployed. By abstracting away the complexities of server management, it allows developers to focus on writing code and delivering value to users. The key benefits of serverless computing include automatic scaling, cost efficiency, and the ability to build highly responsive, event driven applications. Whether it's for building web applications, processing data, or deploying microservices, serverless computing offers a flexible and powerful solution for modern cloud based applications.